So in lesson 3.3, we're going to be talking about solving inequalities using multiplication and division. Again, we're going to use the same rules that you learned when you were solving equations, but there is going to be one added rule that you're going to have to memorize and learn and remember. So when we get to that, I'll show it to you. Example 1, solve and graph x over 2 is less than -1. So again, you're just going to treat these like you did equations. Look at x. This is what you're trying to isolate. You have it being divided by 2, so you need to do the opposite, which would be multiply by 2 over 1 or by 2. You can also look at that as a fraction buster. Your LCM was 2. And there were 2 terms, so you multiply by 2 twice. These 2's cancel. You have x is less than -2. And then when you go to graph it, you have to always ask yourself open or closed dot, because it's not or equal to, it's not shaded, so it's open. And then check with a number like 0. Is 0 less than -2? No. So since this side is no, you already know that side is yes. Or check one of these. Is -3 less than -2? Yes. So this is your shaded side. So again, on the left, you're just going to say isolate the variable using inverse operations. So let's look at another example. Example 2 in the book actually shows you 4 graphs and asks you to pick the one that works the best, but I'm just going to have you solve and graph it again. Solve and graph -2/3 n is less than or equal to 2. Alright, so again, you're looking at, this is the variable you need to isolate. How are you going to move -2/3 over? You're going to multiply by the reciprocal. And you always keep the sign the same because you want that negative to become positive. So you multiply by -3 over 2, multiply by -3 over 2. When you multiply a negative times a negative, you get a positive. 3's cross cancel and become a 1. 2's cross cancel, become a 1. All you have left on this side is n. When you multiply here, notice your 2's cross cancel, and you just have -3. Now, I didn't put in my inequality because I need to talk to you about the rule that I told you was going to be new. Whenever you take a negative and you multiply it or divide it across this line, you have to flip the inequality around. It's only when you're multiplying or dividing a negative across. It's not about what your answer ends up being. It's not about multiplying or dividing to a negative number. It's literally only when this number right here is multiplying or dividing to a variable and it's negative and you're moving it to the other side. That's the only time you're ever going to do that. So you just flip that around and now you have the correct inequality. And that works if you think about, because of positive and negative numbers, you just took the negative from this side and moved it to that side. Well, negative numbers are going to change the value of that. And so it's going to make a difference, and that's why that turns it around. So let's add something to the left. This is your rule. This is the new rule that you need to memorize. When a negative is multiplied or divided across the inequality. Part of the reason we think about that line all the time. The inequality needs to change directions. Okay, so that greater than sign would become a less than, or a less than becomes a greater than, or a less than or equal to becomes greater, a greater than or equal to becomes less than or equal to. A less than or equal to becomes a greater than or equal to. Only when you multiply or divide, not adding or subtracting, and not about your answer being, or the other side being, a positive or a negative at the end. So I want you to try one more. This is going to be 2b. Just hit pause, try it, and then watch me do it and make sure you did it correctly. Negative k over 4 is greater than negative 1. You don't have to graph this one. I forgot to graph that one. So hit pause, try it, and we'll go from there. Alright, so hopefully you tried it. I'm going to go ahead and just cross out and graph there. I think you've had enough practice with graphing at this point. You're isolating k, so you need to move negative 4 over. And if you're thinking about moving a negative 4 over, you can multiply both sides of your equation by negative 4. On the left, those cancel, you get k. What I always do here is I flip it before I even go do my calculations on the other side, so that I don't forget. And then a negative times a negative is a positive, and 4. And if you were to graph that, that would be an open dot. All right, so example 3. It's the same type of question, except you just have to look at how you're going to isolate x. Again, hit pause and try it if you want to. So you should have drawn your line. In order to isolate x, you need to divide by negative 5. And again, you follow that same rule. When I divide by a negative, I flip my inequality around. Now I have x is less than or equal to negative 1. Go ahead and draw your number line. And ask yourself the questions you should be learning to ask yourself. So, open or close dot on negative 1. It should be a closed dot on negative 1 because it's part of the answer. Now try a number you think will work. Try something like negative 3. Is negative 3 less than or equal to negative 1? Yes, it is. So this is your shaded side. If you were to try a number over here, it wouldn't work. Is 1 less than or equal to negative 1? No. Go ahead and hit pause and copy example 4. And once you're done copying it, then we'll go over it together. Now I want you to go through and I want you to highlight or underline any important information you can find. And I also want you to look for one piece of information that's given that's not really important. It's not what we need to know. Hit pause, and once you're done, unpause. All right, now that you looked at it, let's go through and highlight some important information. A case of 12 jars of spaghetti costs $13.75. What is the greatest number of cases the student council can buy if they use at most $216 for this project? So hopefully as you looked through that, you found that this 12 jars per case really doesn't matter unless we're trying to find out how many jars they end up with at the beginning. So you really don't need to know about the 12 jars, you need to know about the cases. It was the case that was more important. One case is $13.75. Then if you want to figure out how many jars that is later, you can. So when you go to set this up, you need to think about $13.75 for a case and then spending it with that. So $13.75 per case of spaghetti. So I'm going to say C equals a case. Has to be something in relationship to $216. And once I look at that, am I looking at it's at most? So remember, a lot of you want to say greater than or equal to because it's most. It's the opposite. This is the highest it can be. It can't go over 216. So it's at least. This is the highest it can be, or it can be less than that, but it can't be greater than it. And then if you're going to solve for that, you divide both sides by $13.75. And you end up with a case has to be less than or equal to 15.71. And again, we have to talk real life here. Real life is they can't buy 16 cases because then they would go over their money. So they have to buy 15 cases. So they can buy 15 cases of spaghetti would be your answer. So you always have to look at if this is going to round down or up based on the actual true application and real life situation that's going on there. And that's the end of this lesson.